Who am I? I'm the author of this book called Software Architecture for Developers. It's a kind of developer-friendly, accessible guide to software architecture. If you read a lot of the classic architecture books, they're written by some very, very smart people, but they're quite dry, quite academic. So I wanted to write a book which, hit home with developers. For those of you who are coming to my workshop on Friday, I will give you a free copy of this book as a bribery for coming along. I'm a software developer, but over the past couple of years, I've been helping teams understand what software architecture is all about, and particularly how we can balance agility and upfront thinking. But I do write code as well, so don't worry, this isn't going to get all scary and fluffy and conceptual. And really what I'm interested in here is the intersection between software architecture and code. So as Ina said, I want to see these things as one and the same thing. Now, you'll recognize from my accent, I'm not local. I'm actually from Jersey. That's Jersey, not Joysey, which exit doesn't work on me. So this is Jersey in the Channel Islands. And I moved back to Jersey about 5 years ago, after working for London for about 12 years. Jersey's fantastic. It's a small island, it's surrounded by sea, and there's lots of things you can do. And when I was a kid, I used to go fishing. And I used to wake up on a Sunday morning, attach my fishing rod to the crossbar of my bicycle, cycle to a local pier, and go fishing. And sometimes I even caught some fish. I wasn't that successful though. When I moved back to Jersey 5 years ago, I actually moved back to Jersey 1 month before my family. And I had some free time, and I figured, well, I could get back into fishing again. So I did. I went to the fishing shop, bought a rod, and when I was in the fishing shop, I saw these little tiny plastic fish, and they're called lures. And I said to the guy behind the counter, what do you use these things for? And he said, well, you can catch sea bass. Ooh, that sounds fun. I've never caught a sea bass before. So we had this chat, and he explained how to do it, and I thought, yeah, I'll buy some. And I went bass fishing. A lot. And I caught nothing, right? I would go out, every other day, every other evening, different piers, different beaches, absolutely zip. The next season comes along, the next summer, exactly the same thing happens. I catch absolutely zero. And at this point, I'm trying to get up really early, go out fishing really late. I'm spending a lot of time doing this, and I'm getting absolutely no results. We'll come back to this later. I'm going to leave you in suspense. So software architecture is often really overrated. Okay, it's nothing more than just looking at the structure and vision of your software system. But lots of people think architecture is about this grandiose visions, conceptual abstractions, and that sort of thing. It's not. It's just how we see the structure of our system in terms of modules, services, components, layers, and how we create that vision. So how do we get to a structure, and how do we share this vision with the rest of the team? So I'm particularly interested in communication of architectures as a way to create a shared common understanding that a team can work from. Show of hands, who uses UML here on a regular basis as part of their job? So it's I know and someone else, right? That's it, 2 people. I've been quite fortunate to do a lot of traveling recently. I've been to the US a few times. I've traveled to 20 plus countries around Europe, Dubai, China. Most people don't use UML, in my experience. Okay, so I've asked this question a lot. Now, UML is kind of the one true standard way that we've got to describe software, and yet, look, we're not using it. So that is a problem. So how do we communicate our software systems? Well, I guess we use no UML, right? SQL, NoSQL, UML, everything else. Just boxes and lines pictures. Boxes and lines pictures are fine, but the boxes and lines need to make sense. And I run training courses and stuff around Europe, and one of the things I've discovered is that people find this really hard to do. They find it really hard to visualize and share and communicate their software systems. And I can now say this with some confidence because part of my training course is to give groups a set of requirements. It's a really simple financial risk system, and the requirements are very, very simple. We have 2 data systems, trades, things the bank sells with other banks, reference data for the other banks. We pull this data together, we merge it together, we perform some calculations, we produce an Excel report. There's also the ability to modify some parameters in the calculations. That's it. That's essentially all the system does. And we get people up in groups and we get them to design a solution. And the output from this exercise is to draw some pictures. This is the type of thing we get, right? Just shopping lists of technologies. People have decided which technologies they're going to use, but not why. We get lots of boxes and no-line style diagrams. This is a 3-tier or 3-layer Microsoft solution. It says ASP.NET at the top. There's a web app, but nobody's using it. People give us a functional view. What's a functional view? It's just a list of things. Different colors, I don't know why. People had different pens, who knows? This is my all-time favorite. This central spine shows the core of the system, 2 source data systems, importing step, calculation step, reporting step, distribute the report. Nice. Car crash. This thing's like London Heathrow, Chicago. It's a big centralized connection point for some reason, don't know why. This is just a mess, different colors, styles, shapes. This box here says UI upside down. Why? This diagram describes all of your software systems that you're working on today. Look, business logic in the middle. We have a system here that does business logic. How super awesome is that? This picture tells you nothing. Then we got the logical view. The logical view is basically anything that doesn't include technology choices, I've discovered. People are really scared to mix technologies onto these pictures. And then we get things like the HOCO, the homeless old C# object, just a bunch of C# things floating around next to a database. That doesn't make any sense. This one's kind of big and complex. When I was a kid, I had these storybooks. You'd start from page 1 and choose your own adventure by turning to different pages in the book. This one's the same. You start at the top, go down, make choices. Eventually you die, end up in the trap. It's all bad. I've got millions of these photos kicking around my laptop. I ask groups. Sorry?
Do people send them to you as they come up with good ones?
No, I just take photos of them.
Oh, okay.
I actually see these being created. So I ask people what they find challenging about this exercise, and they say, well, we don't know what to draw, we don't know how to draw it. Right. Well, this is what UML's all about. But UML's hugely fallen out of fashion. 2 people out of, 50, 60, only using UML. You ask people why, and they say, well, UML's too complex, it's too low level, I don't know it, my team doesn't know it. Or they say, we're agile. We don't do UML because we're agile, and we do TDD instead. TDD seems to be a substitute for architecture in many people's minds. Is this really true? No. For me, TDD, you have to do TDD within a set of boundaries and frameworks, and architecture provides those boundaries and frameworks. So this whole diagramming thing, it's really hard to show everything on a single picture. And when you read these classic architecture books, they'll often talk about views and viewpoints and perspectives. So this is Philippe Crichton's RUP, the 4+1 model. Logical view, development view, process view, physical view, use cases tying the whole thing together. Lots of other models and techniques show exactly the same kind of thing. But they're all different. And the naming often doesn't make much sense. So I've been in meetings where architects have argued the difference between a conceptual view and a logical view. These sound like the same thing to me, but I'm probably a bit stupid to understand it. If I'm a developer writing lines of code, is that the development view or the implementation view? Or maybe it's the design view. But hang on a second, if I'm writing lines of code, if I'm physically creating files, maybe that's the physical view. But no, that doesn't make any sense because the physical view is the infrastructure. But we're all using virtual infrastructure now, so do we have a virtual physical view? The whole thing doesn't make any sense. The key thing that a lot of these mechanisms and techniques share is that they separate the design, the logical type views, from the code. And essentially what you get is, here's our software system in the middle, and we will view it from different angles and different views depending on our interests. And in order to document and communicate your systems, you have to understand this kind of stuff. And this makes my head hurt. Right, I have 2 kids, and they love eating ice cream, and they do it really fast. And what happens when you eat ice cream really fast? You get brain freeze. Now, if you go to Wikipedia, there are some ways to prevent brain freeze. You either drink a hot drink beforehand. Does that work? Well, no, because my kids don't drink hot drinks. The easiest way to prevent brain freeze is to stop eating ice cream. This font is horrible. This gives me a headache. The only way to avoid that headache is to not look at this font. These models of how we break down software system, they make my head hurt. We could look at different views in isolation to try to understand them, or we could just do something different, right? Let's not use those models. We could cheat, right? Forget all this complex views stuff. Why don't we just cheat? If the goal is to create some pictures to communicate our software system, why don't we just look for examples and use those as a basis? How do we do this? We go to Google. Right, so if you do a search for software architecture diagram on Google, you get stuff like this. Page after page after page of block diagram, nicely colored, of course. Cool, so what we'll do is we'll take some of these and base our examples on them. And then what happens? You get stuff like this. Right, so take this one here in the middle. We know that layering is apparently important, so let's have a diagram that shows layers. Some stuff never quite fits in horizontal layers, so let's have these vertical layers, and they're good because they stack the diagram together, stop it wobbling, provide some rigidity. Why the different layers, different colors, I don't know, but at least they're gradient shaded. This is good for PowerPoint. Acronyms, all sorts of stuff here, and these patterns are repeated over and over again. Do you guys see these kicking around your organizations? Enterprise architects love this stuff. So we can cheat. Right, so back to my fishing story. I'm getting completely fed up of getting up really early in the morning, spending lots of time chucking plastic fish in the sea and getting nowhere. So I thought, well, I'm going to cheat. How do you cheat when you go fishing? Well, you can either chuck dynamite in it, but that's a bit excessive, or you can buy a boat. So I bought a boat. Now you're probably thinking, yeah, 30, 40 foot long, nice cabin, maybe a little galley. I should probably caveat what I mean by boats. What I really mean is kayak. 2 of them, bright yellow and plastic. And this is nice because, you know, Jersey's a very pretty place and you can go and bob around the island and just drop your fishing rod over the side and hopefully catch some fish. And I did. Right, so I caught my first sea bass on my kayak. But the thing is, even my kids can catch fish off my kayak. All we do is we paddle out a bit, we drop some feathers off the side, we do this for a bit, and then mackerel pop out. I love this photo, look. My oldest here has caught the fish, he's really happy. My wife's really chuffed, and my little son in the middle is crapping himself because he's about to have a bunch of fish dumped on his lap. Poor little thing. Kind of feels unfulfilling though. Right, I've caught some fish, but I've not done it. It feels like I've cheated. We'll pick this up again later. Code, let's attack this from the other perspective. Right, so what happens if we think about code? Well, what's the purpose of these pictures? The purpose of these pictures we're trying to draw is to answer a couple of basic questions. If we're doing upfront design, it's this question we're trying to get to the bottom of. You know, is this what we are going to build? If we're retrospectively documenting a system, then it's this question: did we build it that way? Is that what we coded? And really the code is the single point of truth. Right, the code is the embodiment of the architecture. Now let's imagine we have a huge enterprise system, 250,000 classes. Are we going to draw a diagram with 250,000 boxes on? Hell no, right? Because you'll never ever get to the end of it. So what we do on these diagrams is we talk about abstractions. And abstractions are a way to, you know, clump stuff together and prevent a simplified view of the world, in this case our software system. And why do we do this? It's because abstractions allow us to reason about a big and or complex system. Right? They essentially allow us to remove some information, remove some noise, remove some detail. And this raises a bunch of rather interesting and tricky questions. When we're drawing these pictures of abstractions, do those abstractions map into the code? Right, so if we draw something as a layer or a module or a component, can we see those concepts in the code base? And the answer is often not really. Because if you take Java, if you take C#, it doesn't have a component keyword. It doesn't have a layer keyword. It doesn't have a service keyword. Because we're thinking in terms of classes, namespaces, packages when we're writing code. And these concepts are different from the ones on the pictures. Show of hands, who uses a layered architecture here? Wow, that's tiny. What's everybody else doing? Are you coding? The traditional way, I actually did this talk yesterday in London, and everybody put their hands up when they said that, when I asked them if they were doing layers. That's why I'm surprised. So this is your typical layered architecture, right? So presentation layer, business layer, data layer. Put some boxes in the layers, wire them all up. That's how a lot of people approach software design, software development. Perceived wisdom. Why? That's what the books tell us to do. This is chapter 1 from a Spring book. Structure your apps in this way: presentation tier, business tier, data tier, blah, blah, blah. You turn over the page, it describes the different layers, the purpose of them. This line is quite interesting. Spring aims to decouple architectural layers so that each layer can be modified as far as possible without impacting other layers. This is basically just about isolating the impacts of change. If you download tutorials for the Spring framework, for example, this is your sample code base. Domain package, repository package, service package, kind of sound like layers. You go on to Stack Overflow, how do I structure my code base? People give you the same sort of advice, exactly the same in the .NET world. Perceived wisdom. This is the way we should do stuff. Right, so back to my fishing story. I still want to catch a sea bass by standing on Jersey and not bobbing around, around it in a kayak. So I try again. And I go and, try some different things. And I talk to a few people, and they say things like, well, you should go fishing at low tide. And I'm like, if I go fishing at low tide, there's no water by definition. So how's that going to work? And they go, no, you're fishing in the wrong place. What? So it's kind of challenging all this perceived wisdom I've built up over the years. So I thought, I'm going to have to go and buy a book. So I went to the fishing shop and I bought a book on bass fishing. And this book's like 20 years old. And it's got some fascinating stories in there. Now, the thing about bass fishing is that it's very secretive. Nobody's actually going to tell you the answers and their secrets, particularly if you ask them for spots to go fishing. And this is a great book, and it's got lots of tips and techniques, but they're kind of abstract. They don't really tell you what to do. If this book was written by Yoda, it would basically say this: find the fish and you will catch them. Well, thanks. Right? You have to find the fish to catch them. Yeah, I get that. But it does challenge some of my perceived wisdom. It makes me think about different places to go fishing, different times of the day, different techniques. Actually having a method to my madness of just chucking stuff in the sea and hoping for the best. Throwing my little fishes at rocks, for example. Again, we'll park this and come back to it later. This is your typical layered architecture, except it's not, because that happens. Right, so we all know that layered architectures tend to get corrupted very, very easily. So the way we implement layered architectures is, each of these is a different package or namespace, and in order to call stuff in different packages and namespaces, that stuff has to be public. And once something's public, it can be called from anywhere. So these architectures tend to get corrupted quite easily. And this is what ultimately ends up in those horrible big balls of mud. Now, there are different ways we can structure our software systems. We can use hexagons and onions and clean architecture and stuff like that. These are all different ways to structure our system and think about our system, but essentially they're still layered. Right? We can redraw our layered architecture like a circle, stick stuff inside it. Stuff still has to be public. We can still corrupt it. So maybe layers are bad here. Maybe layers should be considered harmful. Some of you might find that controversial. Some of you might be going, yeah, I hate layers. It's an appalling way to build software. I'm not going to answer that. I'm going to let you mull that over in your heads. What I will ask, though, is this question. These layers we've got in our software, are they our significant building blocks, or are our significant building blocks something else? So in other words, a layer is just an implementation detail that we're looking at too closely. There's a guy called George Fairbanks. He's written this book here, Just Enough Software Architecture. Brilliant book, definitely recommend it. And he identifies this thing in this book called the model code gap. And essentially it says your architecture models are going to show different things than your code. And really what this is talking about is, you view your architecture differently from your code. And a lot of this comes down to how you organize your code base and therefore how you reflect that organization onto architecture pictures. And in George's book, he runs through a whole bunch of different types of ways of modeling systems, and they all essentially do the same thing. They break out the code model from the rest of the world. Design views, logical views, module views, and whatever. So how do we shrink this model code gap? Well, the obvious answer is merge the two things together. Right, merge the model and the code. We tried this 10, 12 years ago, model-driven architecture. It's awful. It didn't work. Putting lots and lots of information into a UML model, pressing a button, getting code out. Right, so let's dump that and let's flick this on its head. And what George says in his book is that you can use an architecturally evident coding style. In other words, you drop hints in your code base to reflect your architectural constructs. You have a component, you have a service, you have a layer. You make sure those things end in the word component, service, layer. You have a packaging convention which says all of the stuff related to a single service is in this package, in this namespace. Does anybody do this? Wow, tiny number of people, yeah. Again, that's my experience of kind of consulting around Europe. Nobody does this. Perhaps we're looking at this the wrong way. Perhaps these models that we're talking about, we shouldn't be drawing them by hand. Maybe we should be automatically generating these pictures. But we can't. Right, it's 2014, and there are a bunch of tools out there that can draw architecture pictures, but they don't work. They fundamentally don't work. Why? Because they see the things we do as developers. They see packages, namespaces, classes, interfaces. They don't know what a layer is. They don't know what a service is, a component, a module. They see the same basic constructs, and therefore that's what they reflect on the diagrams. Structure 101, lattice, end-append, sonar, etc., etc., etc. They all give you package dependency diagrams, class dependency diagrams. They show you stuff like this. If you've got a big ball of mud, these pictures are just going to be horrible. You've got a mess. You don't need a tool to tell you that. So something else to think about is maybe the languages we're using are not suitable for the types of systems we're building today. Maybe we need a language with, components, services, layer as first-class citizens. Or maybe not. So how do we merge these two worlds? Well, how do we merge architecture and code and make them one and the same? Well, any models we do produce should reflect the code. The two things should match up ideally one-to-one. And the way to do this is to make sure you get your abstractions correct. Now, UML gives you two things. UML gives you a standard set of abstractions, classes, components, packages, use case bubbles, that kind of thing, and a standard set of boxes and lines notation to describe it. Whenever I see people using UML, guess what they do? They abuse the abstractions, and the typical example is we have a class on a class diagram. It represents a system or a message bus or something. Or they abuse the notation. I've seen people drawing boxes and lines diagrams with a UML class diagram, and they just take out all the compartments to make it look like an empty box. It's like, why are you using an expensive tool? I don't actually care how you draw pictures. So my workshop on Friday is about drawing pictures, but I don't care how you draw pictures. I care about abstractions. And the way that I think of a software system is very simple. So my software systems are made up of what I call containers. A container is just something like a web app, a web server, an application server, a database, file system, a mobile device, a browser, a Windows service, that kind of thing. It's an executable thing, somewhere that we can put code or data. I'm a big fan of breaking my systems up in terms of components. So my containers contain components. Now, I grant you this is a hugely overloaded word. What's a component mean? Bunch of stuff, related, cohesive, encapsulated, with a nice clean interface on top. Because I mostly build systems in Java and .NET, my components are made up or built up of classes. These might be functions, might be database tables, depending on your technology of choice. It's a simple tree structure. Software system made up of a bunch of containers, each of which has components. Those things are made of classes. Right, with this in mind, with this set of abstractions in mind, we can then draw pictures at different levels in turn. We can have a system context view of the world, which shows your system in the middle, stuff around it. We then zoom into your system and we show the containers. And that gives you the high-level shape of the system. We then zoom into those containers in turn and we see components. This is normally where I stop, but you'll see the number 4 up here. You can go down to classes if you want to. You can start diagramming out classes, the internals of components, but I don't normally do that. It's normally too much detail. An example with some monkeys. This is a system that I built. It's called techtribes.je. It's just a content aggregator for the local tech community in Jersey. This is my tech tribe system. These are my key types of users. These are my system dependencies. I zoom into the monkey, I blow him up. This is my containers picture. It shows my web server, my standalone process, and my databases where I'm storing data. Again, it's just a high-level shape of the system. I zoom into one of these boxes. We see components inside it. We've got like a Twitter connector component here, and a GitHub connector, and a newsfeed connector. And this is how I decompose my software system. And these diagrams are essentially like maps. So if you go to Google Maps, and you do search for Jersey, for me, it gives me this. It might give you New Jersey, but that's a different story. And it gives you a zoomed-in view of Jersey. And this is great because it tells you, where the roads are, where the airport is, where the beaches are, all that kind of stuff. But if you don't know where Jersey is, you need to zoom out a few levels. And eventually you get to that, which shows you where Jersey is in conjunction with the rest of Europe. The diagrams should also be like maps. Sometimes we want the zoomed-in view of the world. Sometimes we want to zoom out and see the system as a whole. Now, this is just the way that I think about software systems. It's not necessarily about creating a standard, but what I want to do is give you some other ideas here, some other ways to think about your systems in your head. And what this model I've just presented does is it basically puts the static structure of the system right at the core. From the code and classes, all the way up through components, containers, and the system. And once you understand your static structure of your system, other stuff falls into place really easily around it. Your runtime, your behavioral models, if you want to draw them, are simply collaborations across components. Your deployment mapping is basically containers onto infrastructure, and so on and so forth. And what this basically does is it says, look, who's the major stakeholder for this stuff we're doing? For me, it's us as developers. The reason I document software systems is for developers. It's because either I want something I can maintain in the future, or I want to set the scene. Here's a blank sheet of paper. This is kind of what we're going to build. This is how I envisage that we're going to build it. And my C4 model is basically just putting the static structure at the center and admitting that developers are the key stakeholders. With this in mind, you can then ask this question. We have these diagrams, we have these models. Does it map to the code? Does it reflect the code? And if we do have diagrams kicking around, if we do have architecture models, and they don't reflect the code, the diagrams are basically pointless. We're just deceiving ourselves. We've created like an alternate reality about how we think the system should look, but it doesn't. Now, I just briefly presented you some diagrams that I drew based upon a real system that I built. So we can ask the question, my diagrams, do they reflect the code and vice versa? And the answer is, you can go and look this up yourself because it's on GitHub. The answer is yes. Hooray! I'm super awesome. Right? I've got a nice clean mapping between my code and my architecture. Okay, so there's a tweak component here, and I've got this nice convention that says, there's a whole bunch of components all nicely, neatly packaged. How cool am I? This is epic. Apart from being a bit of a smartass now, this is a more interesting question to ask me. Did it start out like this, or did I manufacture this situation? And the answer is, not really. So I drew these diagrams for my training course in my book, and I did have this nice concept in my head of, there are a bunch of components in my system. But when I looked at the code, it didn't match. So even I was creating this fantasy about what I thought my system looked like. Why? Because I did exactly what everybody else does. I used layers. So this is built in Java. I had a services layer and a data access layer. So I had this concept of a tweet service, which basically stores tweets in a Mongo database, and there was a tweet service which gave you access to that information. Interface, because I'm writing everything in Spring and Java, so you have to have an interface for everything, and a default implementation with a bit of business logic. Delegating down to a tweet data access object, Mongo implementation, right? Standard layered architecture, standard implementation. So while I've created and built a layered architecture, in my head I'm thinking, well, this is a single component. And as I said before, this stuff has to be public, which means anyone can call it. So it's easily corruptible. And a component is really these two things kind of jammed together in a really horrible way. Two options. Option one, change the pictures. Didn't like that. Didn't reflect my nice idealistic view I had in my head. Option two, refactor. So now the code looks like this. So essentially I've merged the layers. I have a nice tweet component interface with a bunch of really, really simple operations. There's an implementation, which is essentially this thing. And there's my Mongo tweet data access object, which is essentially this thing. That's public. These two things are package protected, so you can't see them. We have nice encapsulation here. This is cool. Originally, I had this tweet data access object in here as well. It's not used, so I binned it. I threw it away. Some people, when you show them this picture, they go, well, Simon, what you've done now is you've not created a layered architecture, and therefore you can't change your database to be something else than Mongo. I can. I still have layers, but they're internal layers. So this whole thing about, are layers significant or are they implementation details? Here, my layering's an internal implementation detail. I can still switch out my data access because I've got a way to essentially isolate change in this one class. But the people who love testing and TDD go, this is really bad because you can't mock out that thing now. Right? There's no interface for you to mock, and there's no way for you to inject your data access object to this because it's all wrapped up in a package. There are some workarounds here. Right, we could create another parallel package structure in a separate source code repository, create some abstract stuff, make an injection point here. We can have some workarounds to, inject a mock implementation of my data access object. I can't be bothered. Right? It's too much hard work. So, screw it. I'm just not going to unit test the whole thing. Right? So just don't do unit testing. Who's seen all the stuff about unit testing at the moment? Unit testing being considered wasteful? Right, so this is going to be a quick educational thing. There's a great paper by a guy called Jim Kaplan, and he basically says most of what we're doing in terms of unit testing is complete utter waste. The whole point of unit testing and mocking and that kind of thing was, if you look back 10 years, databases were slow, infrastructure was slow, so therefore let's put in injection points, we can mock stuff out, and then we can write unit tests against local storage, in-memory storage, that kind of thing. And we can speed up the feedback cycles. It's an interesting paper. I don't agree with all of it. You might not agree with all of it either. Something else Jim says is that if we've got a system with a bunch of tests, maybe we've got a horrible design. And maybe our developers don't really appreciate how to design software well, which is an interesting way to think about this. DHH, the Rails guy, he jumped on this. He's like, yeah, unit testing is awful. So DHH created Ruby on Rails, really simple way to build database-driven web apps. A lot of that stuff is done for you. A lot of the plumbing is done for you. In order to make your Ruby on Rails code testable, you have to start chopping stuff up with interfaces, injection points, that kind of thing. And in this blog post, DHH says, yeah, this is basically damaging our design. It's damaging the clean design that Rails gives you. And he says you should not let your tests drive your design. It's just crazy. And again, you may agree or disagree with this. But he's got a point. Right, there are some really interesting points being made here. What's the purpose of layering? Well, it's to make sure that changes are essentially isolated. So if we want to switch out our database, we do it in one place. If we want to switch out our integration with an external system, we do it in one place. And maybe we should see this separately from our tests. Maybe we should be thinking more about our design. So with my Tech Tribe site, there's a bunch of stuff that just does not get unit tested anymore. And instead what I do is I do component testing. Right? I test that component as a single thing, including spinning up Mongo, chucking stuff into Mongo, and then bringing it down again. And it's super quick. So I can do true component testing on a bunch of stuff in my code base. Now that's not applicable for everything. You know, if I'm dealing with asynchronous systems or email or systems outside of my hands, component testing, integration testing is kind of hard to do. So you still want to do unit tests and mocks. But maybe we should be unit testing or testing our structural elements. Maybe that's something that we want to be striving for instead of just blindly unit testing everything. And that's exactly what this is all about. You know, don't blindly copy what everyone else is doing. The whole layered architecture thing, the whole doing TDD and unit testing and mocking, why do we do that? Maybe we should question the value that these things are giving us. Back to my fishing. I tried and I tried and I tried after reading this book. And eventually, I caught a sea bass by standing on Jersey and not bobbing around the island. And this was amazing because finally all of this practice, all of these different things I was experimenting with finally came together somehow magically, luckily. I did see people fishing. You know, when I'm driving around Jersey, I saw people bass fishing. And I kind of try and copy what they were doing, just chucking these things in the sea and reeling them back in and that sort of thing. You have to experiment. You have to change what you're doing. If you repeat the same thing over and over again, you'll get the same result. And the systems that we build are all different. So maybe that technique we followed last time is not applicable for this thing we're building this time. So you need to think about what you're doing. And you need to understand why you're doing it. And once you understand something, you can teach it to others. So of course, the first thing that happened when I went home with my stories and my photos of my sea bass is my family goes, cool, can we come fishing too? I'm like, oh no, this is going to be another 3 years of pain. So now I can teach them how to fish as well. Just a point about fishing. If you ever take your wife out fishing, make sure she doesn't fall off a rock. This was 2 weeks ago in Jersey. My 7-year-old finally caught a fish on his own by casting out, reeling it in. He's going, Daddy, Daddy, I caught a fish. His fishing rod's doing this, bouncing around. Daddy, Daddy, I really have caught a fish. I was like running over to him, trying to pick this thing up. And he was really scared holding it. It's brilliant. So what's the point of all this, apart from me catching fish? The point of all this is that a good architecture enables agility. So this is something that we're all striving for. We're looking for, software systems that are easy to maintain, flex, change, enhance. And this is really the goal. But in order to do this, we need to think about the design. We need to build adaptability and agility in. And of course, there are different styles of architectures. Right, we've got the big monolithic balls of mud here. Easy to build, quick to build, bit of a pain to maintain. On the other end of the spectrum, we've got microservices and service-based architectures, lots of individual, loosely collaborating things. Gives you lots of flexibility, lots of agility, because we can change any of these services independently, provided certain constraints are met. A bit more complex to implement, design. You can have collaboration to worry about, that kind of thing. I'm looking forward to Rachel Laycock's talk later. I think she's going to demystify some of this microservices stuff. And kind of, you got something in the middle. You can still have a monolithic deployment unit with a nice, neat structure inside it. Components, modules, services, layers, whatever you want to call them. But you have to think about this. You have to get it right, and that gives you agility. And the structure of your software system, and therefore the decomposition strategy used to get there, are really, really important. And there are lots and lots of different ways we can decompose our software systems. And what I will suggest is maybe layers aren't the best option always. Right, there are other things we can do here. Agile approaches talk about retrospectives and inspecting and adapting. If we want to build an agile architecture, we need to apply the same mantra to our system. How do we inspect a system? How do we look at a system? Well, we can draw some pictures, we can create some models. And those models, as I said, they have to match the code. Otherwise, it's pointless. Once you understand your system, then you can adapt it. Right? People say that architectural refactoring is really hard to do. It's not. If you understand what you have, truly what you have, and you understand where you want to get to, it's a simple transformation process. It's simple refactoring. And this is why we should think about how to align the software architectural view of the world and the code, because it allows us to make these transformations much more easily. And a simple, explicit mapping between the diagrams and the code really, really helps. It's easier to explain. It's easier to do architectural refactorings. It's just easier to work with. And until we do find that one true silver bullet, we have to think. So that's the thing I'd really urge you to do. Don't blindly adopt that layered architecture. Think about other ways you can structure your software systems. Think about other ways you can decompose, maybe into components, maybe to services, maybe to modules. And think about how to relate these things to the code. And my final point is very, very simple. If your software system is hard to work with, change it. This is entirely within your hands. Thank you very much.